Okay, question 15 is all about vectors. We have a parallelogram here. It says ABCD is a parallelogram. The diagonals of the parallelogram intersect at O, right in the centre there. OA equals small a and OB, vector OB equals small b. The line above means vector. Okay? Write an expression in terms of A and or B for part 1, vector CA, part 2, vector BA, and part 3, vector BC. Let's have a look from the diagram. Now, let's see. Because this is a parallelogram, we need to know a few things. This is the same length as this, so OA is the same as OC, and 2 marks on this one, OB must equal OD. We'll start with that. Right, so we want CA, so we want from there to there. Now OA is A, so that's the same length, so CA must be at A as well, so it's A plus A, which is 2A, small a. Okay, let's have a look at the next one. Vector BA, we're going from there to there. So we can only travel down the vectors that are given. We can only go in this direction or this direction. We can go any multiples of that. We can go backwards, but we can only go in those directions. So to get from B to A, we need to go down there and up there. So that is in the opposite direction of B. So that is minus B plus A. You must do them in the letters that they're given. BA, you can't go from A to B. It must be from B to A. Let's have a look at the last one. BC. B down to C. So we can only use these directions again. So we need to go down there and down there. So that is minus B minus A, because it's the opposite direction. That's A, and we're going the opposite direction. So minus B minus A. And that's it. It's pretty straightforward, that one. Let's have a look at the next one. We've got X is a point such that OX equals 2A minus B. So let's draw this on the diagram. OX equals 2A minus B. So there's O. So 2A, wait, there's 1A. So let's have another, extend that. I'll draw it on. That is 3.3 centimetres, so I'll draw another 3.3 centimetres to make it 6.6. And it says 2A minus B, so I need to go down. B is 2 centimetres, so I'll go parallel to that, 2 centimetres down. There. And that is going to be X. There. I'll just show you that again. It says OX equals 2A minus B. So we go 1A, 2A, opposite direction, minus B. So that's it there. That's another A, and that's minus B. It's the opposite there. Okay? That's one of the diagrams. Now find an expression in terms of A and B for AX. So let's have a look back where A is. Look at the diagram. A is there, and we need to go to X. So A is simply A minus B. So I put that back in here. A minus B. Now part 2 here, B part 2 looks quite tricky. It says B, A and X lie on the same straight line. Explain why. Now what we need to do is we need to pick a few of the points here. So if I do, you could do a few different ones, but I'm going to do vector BA. BA, and then I'm going to do vector BX and see if they are on the same line, they should be in proportion. So let's have a look. BX is the other one after. So BA, have we done that? Yes, this was early on. Part 2, BA is minus B plus A. So that's been given. Minus B plus A. Okay, that's already done. BA was minus B plus A. Now let's have a look at BX. According to this, I mean, see from the diagram above, you can see that the diagram I drew, they look as if they're on a straight line. Now I didn't draw it exact, but it's telling us that they're on the straight line. We have to prove that. So there's the straight line going along there. We want to prove that. So now going back to here, I'm looking for BX. So cutting back the diagram, BX here. I need to go from there to there. So that's minus B, plus A, and then another minus B. So I'll put them in. Minus B, plus A, minus B. I'll simplify that. That equals minus 2B plus 2A. Now it says, go back to the question. B, A and X lie on the same straight line. So if we look at this, for BA, we've got minus B plus A, and BX, we've got minus 2B plus 2A. You can see that the corresponding parts are in proportion, so they must be on the same line. So I'll write that. The corresponding parts are in proportion, so B, A and X must lie on the same straight line. Okay, that's it there. And that's the finish of that question.